so number 8, we did number 7 yesterday. Both 7, 8, I think it was both methods. So let's have a look at this. Calculate the moment of inertia of the solid generated, of the solid of revolution generated when the area between the curve y is equal to ln x, the x-axis, the y-axis, and the line y is equal to 1 rotates about the y-axis. So rotates about the y-axis, that means we're finding I, y, the moment of inertia about the y-axis. So the main thing, the main part is the sketch. We need to sketch the graph y is equal to ln x. So here, if I have y is equal to k log of, let's say, bx to the base a, so it's a log graph. Your ln is a natural log, it just has the base e there. So we could have one of two shapes. So when you have your log graph is the inverse of your exponential graph. So your log graph will only pass through the x-axis. So it could be increasing, this is increasing, or it could be decreasing. That means as x gets larger, the y value decreases. So now, what determines the shape of the graph? So remember that this is your x-intercept, this is your x-intercept. Right. Now, for your log graph, first of all, a must not equal to 1. The base of the log must not equal to 1 because log of 1 is equal to 0. And if you use the change of base law, you'll get a denominator of 0, which is undefined. You can see here the graph is undefined at x is equal to 0. So the base must not equal to 1. But now, if your base is greater than 1, then your graph will be increasing. If your base is in between 0 and 1, then it will be decreasing. That's what you need to take note of here. Right, it's the base. Now, you can work out the x-intercept, you can use a table, but the main thing is to have a picture in your mind of the basic these two shapes. Right, because you're only going to get around 2 marks or 3 marks for sketching the graph. Now, here, let's have a look at our graph. Y is equal to ln x. Let's sketch this graph. First of all, what is the base of your natural log? So if I got y is equal to ln x, the base is e, and e is equal to like 2,718, 2,718281828. It's not exactly 2,718, it's equivalent to 2,718. But the fact is that this is greater than 1. Can you see that? Your base is greater than 1, so your graph is going to be increasing. Now, let's sketch this graph. Now watch how I'm sketching this graph. I'm not using any table. Right? Although, for your understanding, you can. Obviously, it's best to use a table for proper understanding of all the points. But in the exam now, there's only certain critical points that we're looking for. First of all, we got ln x. We know that this graph is increasing, so there is your curve. Okay, there's your curve. What is the x-intercept here? Let's work it out. Let's work out that x-intercept. So, For my x-intercept, you're going to let y equal to 0. Right. For any graph, x-intercept means on the x-axis, your y values are always 0. So therefore, I will have ln x equal to 0. So I'm replacing y with 0. What is the base of your natural log? It's e. Now, in order to solve for x, we need to convert from log form to exponential form. So, x is going to equal to e to the power 0. What happens here? In this equation, in the log equation, the base, basically your base here in the log equation becomes the base in your exponential equation. E to the power 0 is 1. So this is a value 1, 0. Now, what else do we need to sketch? Calculate the moment of inertia of the solid generated. We got y is equal to then x, the x-axis, the y-axis, and the line y is equal to 1. So where is that line y equal to 1? It is a horizontal line. So there's y is equal to 1 here. So what do we know? When y is equal to 1, what is x at this point here? It's 0. Now, look, I did not use any table. Can you see there was no need for me to use a table to get all the values? So, there's only certain values that I'm interested in. I'm interested in this value, that value, and also this value here. What do you notice about this point here? This is a point of intersection. Right, so we know this point is 0, 0. We know that 0, 1, 1, 0. Let's find this point here. So we know this, the equation of this line is y is equal to 1. The equation of this line is y is equal to ln x. So I know for a fact that at this point here, y is equal to 1 because it's a horizontal line. It's parallel to the x-axis. There you can see that the y values are always the same. So I want to know when y is equal to 1, what is x equal to? So this is a point of intersection. I can substitute into this equation here, y equals to ln x. So what would I do? So let me just write that down. Point of intersection. At this point here, y1 is equal to y2. Now you might wonder, what is y1, y2? We didn't label it. Let's call this y1, let's call this y2. At any point of intersection, the y values are the same, the x values are the same for both graphs. So therefore, what is y1? It's ln x. What is y2? Is 1. In other words, where is ln x equal to 1? So again, go back to your log equation. This is a log equation. What is the base? E. To solve for x, you convert from log form to exponential form. So x is going to equal to e to the power 1. So the value at this point here is e to the power 1, which is 2,718. If you round it off to 3 decimal places, we are not rounding off anything here. This is not the final answer. Okay, so now remember, do not go and round off anywhere except the final answer only. Now, right, so we have our picture now. We can see that area clearly. Now, this is the area. And you can see this part here is the area. Let me just shade it in there. So this is the area. You can see that. The area bounded by the curve, the x-axis, the y-axis and the line y is equal to 1. Now, this graph rotates about the y-axis. So what are we going to do? It rotates about the y-axis. Okay, so now we need to make a decision. We need to make a choice whether to use delta x or delta y. So let's see.
So,
Yes.
so if it rotates against on the y-axis, would it we use the delta y then?
Okay. The question is, if it rotates about the y-axis, we are finding the moment of inertia about the y-axis. Right. It has nothing to do with whether you're going to use delta x or delta y. Right. So what you put here is your choice. You can put anything you want to, but as soon as you draw a representative rectangle, then you need to check them. Like exactly what I'm going to explain now. So let's go with delta y first. Okay. Why do I say delta y? Because it is going to be, by now you should understand that you do not want to break up the area into two pieces. Okay. So if you're using delta x, which I am going to use in this, I'm going to start with the easier one first and then the more difficult one. So let me show you. Let's use delta y first, so you will see. This is delta y. Okay, so this area rotates about the y-axis, that is the question. Now what do we know? We know that this representative rectangle, delta y, is perpendicular to the y-axis, which is the reference axis. Okay, so a choice that I have made. What did I do? I drew this representative rectangle, and it happens to be perpendicular to the axis that we need to find, that we need to rotate about. Right now, what does this mean? If it is perpendicular to the reference axis, that means when we work out volume, we will be using the disk method. The disk method is area of base times perpendicular height. The formula is pi r squared h. When we work out volume, that's what we're going to be using. Now, when we work out also for moment of inertia, we are going to be using the formula mass times k squared, where k is equal to r divided by root 2. The radius, that's given. You memorize that. Your k, which is called the radius of gyration, it's r divided by root 2. Now, this is a result of using a perpendicular representative rectangle. Okay, this is a result of the choice that you have made. Now in the exam, once you make a choice, and there's no time to go back now. You know, this exam is very long. Okay, and most students will never ever finish all the questions. So you need to be quick. You need to choose a method that will be quick in the exam. Sometimes, most of the time, it is the perpendicular method. But you will find certain examples where the perpendicular method will take too long. But most of the time, the perpendicular method is the easier option. Right, so now, Let's work this out. So we know now. Let's write this down. So I'm going to go delta I y. Okay, delta I y. Why am I writing down y? Because the reference axis is the y-axis. Right. Is equal to mass. So I'm going to go delta m times k squared, which is going to be your radius divided by the square root 2 all squared. Right, now what is mass? Right, so give me just 1 second. Yeah, so as I was saying, what is mass? So we know that mass is equal to density times volume. Okay, m is equal to p v, or p times v. So it's going to be p times the volume, which is delta v y, because we are rotating about the y-axis, times your radius divided by root 2 all squared. Now, your radius, what is your radius measured in terms of? So we are rotating around the y-axis, so your radius is in terms of x. Right, so that's going to be pi r squared. There's a formula here, pi r squared h. So it's going to be pi x squared, and the height is delta y. And your r again is going to be x all divided by root 2 all squared. Now, let's simplify this. We can square it. So that's going to be p pi x squared delta y, and that's going to be x squared. Square root 2 squared is 2. Now, we end up with p pi over 2, and x squared times x squared will be x to the power 4 delta y. And that is the formula. Okay, that is the formula. Let's write down the total now. So that's going to be I, y there. So your constants are p pi divided by 2. So you keep that in front of your integration sign. And then we are integrating with respect to y. So that's going to be d and c. And as soon as I put in my integration, delta y now needs to be written as dy. Alright. So now I got my x to the power 4. And this is the formula for moment of inertia, perpendicular situation, single graph. Okay, this is how it comes about. Now, what do we need to do? Right, we need to get x in terms of y. Okay, you can see what is x. X is the radius, the distance from there to there. So what's touching here is this graph here. Can you see that? What's touching the rectangle on the left is the y-axis, on the right here is the graph. So this is the graph that we need to deal with. Y is equal to ln x. We need to get x in terms of y because we are integrating with respect to y. Let me give you 1 minute. We just did it twice over here. We got x in terms of y. Let me allow you to do that quickly. Right, so you would have had to make x the subject of the formula. So what do we know? We know that y is equal to ln x ln x to the base e is equal to y. Right, so what did we do here? When we solve for x, we made x the subject of the formula. That's exactly what we did. So, what is x? X is going to equal to e to the power y. Right, now, what are the values that we're going to substitute? So, what are the values that we're going to be using? So, since this is dy, you use the bottom y value and the top y value. Check extreme bottom, the bottom part of the area, and the top part of the area. So in the bottom, y is equal to 0, and the top, y is equal to 1. So that is going to be 1 and 0. Now, x, what is x? X is e to the power y. So this is e to the power y, but the whole thing is raised to the power 4. So now it is your exponent law. If you do not know your exponent law, then you start at this step here. You will not, and you didn't even start working out anything yet. This is just substituting, getting the formula right. Now we haven't integrated yet. Right, all you did was try and substitute, so be careful. You must know your exponent laws. So if you have a power raised to a higher power, what is the rule? Multiply the exponents. Right, so therefore, I got my p pi over 2, that's my 1, 0. Write down the base, multiply the exponents. 4 times y will be 4y. And now look at the integration, how simple it's going to be. When you're integrating k e to the power bx, you do not have to go and use any u substitution or anything here. It's straightforward. E to the power bx all over b plus c, like how we did it in N4. So now this will be p pi over 2. Integrate e to the power 4y. It's going to be e to the power 4y all divided by 4, substituting 1 and 0. So if I substitute 1, I'm going to get 1 over 4 e to the power 4 minus, if I substitute 0, I'm going to get 1 over 4 e to the power 0. And then I calculate it. So I have 1 over 4. To get e on the calculator, it's shift ln. So here I got p pi over 2, and this is 13, 3,9,9,5,3,7,5,1. Notice I am not rounding off anything here. There's no rounding off here. This is not the final answer. You need to multiply by pi over 2. That's times pi over 2. And we get 21, 0.04794443. So that's 21, 0.048. And that is p. I forgot to write down p there, don't forget. There's p rounded off to 3 decimal places. Is that correct? Is that the correct final answer? Okay. So that is method number 1, which is using a perpendicular representative rectangle. Right, so now the second method, we chose delta y first. Okay, now what happens if you choose delta x? So now let's draw my representative rectangle here. So there's delta x here. Okay, now there's the area. This is that you can see the entire area there. Now what's touching the top of the rectangle? What's touching the bottom of the rectangle? Let's see. Remember, this is the entire area. It starts from here. So the entire area is this whole part here. Now, if you check, what's touching the top here is the line, the straight line, y is equal to 1. What's touching the bottom of that rectangle is the x-axis. The problem is, if I have to sketch it here, here's my delta x now. Now, what's touching the top is the same straight line. What's touching the bottom is the log graph. That means this area is now split up into two. And where does it get split up? It gets split up at this point here. Okay, at this point x is equal to 1. So we need to work out two things here. We need to work out this area, or the moment of inertia of this area here, plus the moment of inertia of that area. Okay, and we add it up, and that will give us our total. So let's take a look. So we made a choice, delta x. So what can we say about delta x? So we know that delta x is parallel to the y-axis or the reference axis. So delta x is this representative rectangle is parallel to the reference axis, which is the y-axis. So what does that mean now? If it is parallel, that means volume will equal to the shell method. Volume will be the shell method, and then moment of inertia is going to be mass times the distance from the y-axis on square. Right. So now let's work it out. So these are the two things that come about if it is parallel. So now we know that delta I y, that's moment of inertia about the y-axis. The same question, just that we change the diagram. We're choosing delta x. So now mass, we know that mass is equal to, m is equal to p times v. So mass is equal to density times volume. So that's going to be, there's mass here, so let me just go delta m first. Distance from the y-axis. So from the y-axis, we are measuring an x value. So distance from the y-axis will be x, and that's all squared. Now, what is mass? Density times volume. And then we got times our x squared. So there's my p times v. Right, density times volume. Now, what is volume? Right, shell method is equal to circumference times the height times the thickness. Right, shell method. Circumference, you know, you must know the shell method and the disk method. Right, so now, circumference, you are rotating, you are going around the y-axis. So your radius is in terms of x. So you know that circumference is equal to 2 pi r, which is going to be 2 pi x. Then your height, what is your height here now? Let's check the height. The height, then I'm talking about, okay, sorry, I forgot to mention, I'm dealing with the first area. This area here. First, let's call this area A, and let's call this area B. So I'm dealing with area A at the moment. So the height is the distance from there to there. Let's call this here y1. Let's call this y2. Let's call this here y3. Okay. So you know that this is the same y1 on the top there. So your height is a difference between top minus bottom. Y1 minus y2. That is the height. So let's just write that down. Y1 minus y2, and y2 is 0 there on the x-axis, but the fact is there is a y value. And then your thickness is equal to delta x. So this is a revision on volume shell method at the same time. So now we got circumference 2 pi r, so that's going to be 2 pi x times the height, which is y1 minus y2. Circumference times height times thickness, which is delta x, and this is multiplied by x squared. You see that? Now, right, now, let's write down the total one time. So I'm going to go total, IY. So what can I do? I got my constants 2 pi times p, so that's going to be 2 pi p. I'm going to put in my integration one time here. So I got x times x squared, which will be x to the power 3, y1 minus y2. And as soon as I put in my integration, delta x becomes dx. So I'm integrating with respect to x. So that will be b and a. Alright, now, where are we integrating? I'm dealing with area A first, then I will deal with area B. Right. So now, what is area? Now, let's substitute our values here. So pi y is equal to 2 pi p. What are the values to substitute? Where does area A begin? Area A begins at x is equal to 0, and it ends at x is equal to 1. So that's going to be 1 and 0. I'm integrating with respect to x. So that means x to the power 3 is fine, I can leave it there. y1 minus y2. What is y1? What is y1? Go to a diagram. What is the value of y1? The value of y1 is 1. So this is your y1, which is 1, minus y2. What is the value of y2 here? It is 0. And that is my dx. So now, that's going to equal to 2 pi p. That's 1, 0. Well, 1 minus 0 is 1. 1 times x to the power 3 is x to the power 3. And there's my dx. So now, this is ready for area A. Alright, so let's go and do the other one, area B. This is easy to work out. Okay, now let's do the other one. And then we'll work it out. So you can work it out now if you want to, because I am going to work it out in a few minutes. But you need to focus on what's going on the board for area B. Okay, that's the more involved one now, because we got the long graph involved. You can see this. So this was for area A. So this was, let me just write this down. This is for area A. At the moment of inertia, if area A rotates about the y-axis, now for area B, so it's going to be, I'm not going to go and derive the whole thing again. It's going to be, it's the same parallel representative rectangle. The only difference here is it's going to be y1 minus y3 instead of y1 minus y2. Can you see that? Okay. So now I'm going to go I y is equal to, the formula is 2 pi p. We know that. So that's going to be b and a, and that's going to be x to the power 3. The only difference is the height of this rectangle here, which is y1 minus y3, and that is dx. Okay, now 2 pi p. What's my b and a for area B? Area B starts at 1, there's your 1 here, and ends at this point here, which is E. Can you see that? So that's going to be 1 and E, and that's x to the power 3. What is y1? Y1 is 1, but y3, what's touching the bottom here, is the graph ln x, which I call y3 for this problem. So that's going to be ln x. Okay. Dx. Right, so now we can go and work this out. How many minutes do we have left here? So let me give you a chance. You work this out, you work that out, add it up, and let's see if we get the same answer, which was 20, 21 comma something. Right, let me give you a few minutes. Okay, so let's deal with this one here first. That one you would have worked it out, you're going to give me the answer, I'm going to ask you for it. Right, so now, here, this is 1 minus ln x. The fact is there's a ln x here, and there's x to the power 3. This is multiplication. But there is no exact derivative here. So therefore, this is integration by parts. This is integration by parts. Right, so that's going to be 2 pi p integration by parts. So the formula you know is, let me write that down, is f of x, g of x minus the integral of g of x times f prime x dx. And we need to substitute e and then 1. Right. So from your priority list, f of x, let me let f of x equal to everything here, one time. Okay. We can separate this into two problems, so you see. Yeah, but let's do it one time. Let's see what happens when we do it once. Alright. So I'm going to call this part here f, and this part will be g prime. So f is going to be 1 minus ln x. G prime is x to the power 3. So g will be x to the power 4 over 4. Right. So that's f g minus the integral of g, which is x to the power 4 over 4, times f prime. Now differentiate 1, you get 0. Differentiate minus ln x, that's minus 1 over x dx. I'm done. I need to just simplify it. So that's going to be equal to 2 pi p. This is 1 minus ln x times x to the power 4 over 4 simplify this part. A negative times a negative is a positive 1 over 4. X to the power 4 divided by x is x cubed. You can see that. So that is 1 minus ln x times x to the power 4 over 4. Integrate this, x to the power 4 over 4 also. And now let's substitute e and then 1. Let's see what we get. Send me the advanced calculator. Right, so we got 1 minus ln 1 minus, so that's 1 minus ln of x times okay, just double check me on the calculator too while I'm doing this. So that'll be plus 1 over 16 x to the power 4, substituting e. When you're substituting e, you're going to press shift ln and then you press 1 because it's e to the power 1 on the calculator. Alright, so I get 18, 0.9533884 minus I need to substitute my 1 now. Let me just do this. Okay. I'm not gonna go and do this in the calculator. If I put 1 here, then of 1 is 0. 1 minus 0 is 1. So that's just gonna be basically 1 over 4 plus 1 over 16. You get 5 over 16. Alright, so I got my 2 pi p. So that's 18.09533884 minus 5 over 16. And this is 17.828384 times 2 pi. Just double check. Now we're getting the same answer. So this is 111,732,8717. Looks way higher than the other value. Alright, so maybe just double check the calculator, but let me just make sure that. What was the answer for this one here? This one. So this is x to the power 4 over 4, substituting 1 and 0. So that's just going to be 1 over 4. Basically, you just get 1 over 4, yeah? Times 2 pi. So I'm getting 1, comma 5, 7079632 p. So obviously, the calculator, let me just double check my calculator work here for this one. Okay, 1 second there. Alright, so my calculator work was wrong in both places. Alright, so that was the answer for IY. And here, what I made a mistake when I was substituting. So when you substitute A, put a minus sign, and then you substitute 1 again, you get 19,4771797p. Alright, that was the answer for this year. Alright, so now total. So that is area B, that's area A. So the total is equal to 1,570. Why am I writing 7 for 5? 1,570,796,327 plus 19,477,14797p and finally we get 21,047,943p. Oh, I thought I made a mistake with the integration. Lucky that was all correct. The only problem was I made a mistake on the calculator. Alright, so double checking, and that is it the same as the other answer? Yes, so it's 100% correct. Right, we move on to the next section next time.